I'm Dr. Gordon Hamilton, and this is the fourth lecture in the series Climate Change Planet Earth. I'm talking to you from Masters Academy and College, Calgary, Alberta, Canada. Okay, so this is a graph that I left you with last time, and one of the issues with this graph is how to get that data. The last data that we can get from the ice sheets only goes back maybe 1 million years. So how do we get data going back 65 million years ago? So that there's ice sheets here, but we can't get data from them because there's been so much melting and unmelting that we can't get good quality data. So how do we go back this far in time? Okay, here's a hint. There are the ice sheets. You notice that they are high in oxygen 16, and you know that that means that the oceans are going to be high in oxygen 18. We know that as more and more ice builds up, that's going to become even more pronounced. So let's add a little bit of ice and see what happens to the ocean. We add a little bit of ice, and now we've got even higher oxygen 18 content in the oceans. Okay. So how can we use that higher oxygen 18 in the oceans in order to move forward and predict temperature over the last 65 million years rather than just over the last million years like we did with the ice cores? Well, here's an idea. That's shells. Shells are made of calcium carbonate. And so what we have to do is we have to find old shells. And we can look pretty hard, and shells are pretty hard to find. And what's much easier to find are very, very small sea creatures. This is a shell of one of them, very, very small, and that's a calcium carbonate shell. So we can look at that shell, and we can analyze the calcium carbonate has got oxygen in it. So the oxygen 18, whenever this sea creature is building itself, it takes oxygen 18 out of the ocean and it puts it in the shell around itself. And so we can use that in order so we can dig a core in the earth at the bottom of the sea. So this is at the very bottom of the sea. We look at the sediments going down step by step. And what are in those sediments? All these little sea creatures. So we can go there, and the oldest sediments are, of course, deeper down, and the younger ones are at the top. So this is, again, a way to get information about the past, and this past can go truly far back. So here we find out that oxygen 18 was high in the oceans, very high down here. This is when it's very cold, and here high and here pretty low concentrations. This is a simplification. I'm not telling you the whole truth, but I'm telling you enough of the truth. Okay, so what happens around 34 million years ago? That's a question that I kind of left you with last time. So around 34 million years ago, something big is happening. The Earth is cooling quickly. What's the reason for that? Well, to answer that question, we turn to Abraham Ortelius. And he came up with an idea that maybe you've come up with, but he was the first. And he came up with the idea that Africa and South America look like they belong to each other, that they kind of were married and kissing in the past. And he published this idea. He was the royal royal geographer for the King of Spain, and so he published this idea way back then. But this idea was not well accepted even into last century. But now with GPS we can actually measure the continents moving. You can see Australia at the bottom right is moving the fastest. So Australia moving the fastest right now. You can also see that India is not connected to Asia. It's actually has just smashed into Asia So let's go back 55 million years. Oh, first of all, I have to show you the ocean currents. So these are the ocean currents as we currently see them, very generalized. So what we have up here is Europe is being warmed by these currents coming up here. And we also have, very importantly, a very cold current running all around the Antarctic. Okay? So that's pretty important, and that's going to change as we go back in time. So this is 55 million years ago. Some things to note. India crashed into Asia around about 50 million years ago. This is a dramatic crash, slow motion crash. This is not a crash that you would sit up and watch and go, yay! This is a crash that is very, very strong. This is to enormous masses, but moving very slowly. Okay? You could spend a whole lifetime watching them and it would not be exciting. So the mountains, the Everest and the other mountains in the Tibetan Plateau are pushed up because of this collision. Okay, what else happens? Well, about 45 million years ago, very rough dates here. You notice I'm not saying 45 million and 17 years ago. These are very rough dates. I'm using 45 million, very rounded. About 45 million years ago, there opened a land bridge between Australia and Antarctic, so the water could flow through there like it is today. But 55 million years ago, when this snapshot was taken, there is no water going between these two. Similarly, over here, about 35 million years ago, we have this land opening up and the water being allowed to pass between Antarctic and South America. Now, what's the effect of that? Well, let's look at the ocean currents at this time. So you see the ocean currents are warming the Antarctic, and that's why the Antarctic at this time is experiencing such a warm spell. The tropics are actually maybe not even as warm as they are today. So although the global temperature 55 million years ago is much hotter than today, it's entirely possible that the tropics were maybe even a little bit cooler. And that's because these currents could have been very, very strong compared to today's currents. We also have the Mediterranean Sea open at both ends, unlike today. And we also have the Panama Canal area fully open. There's a big gap there between North America and South America. So quite different circulation of the world's oceans. Let's go to 30 million years ago. So this is a little bit more familiar. There's a number of changes that you'll see as we move forward in time. There's going to be the closing off of the Mediterranean. That happened about 25 million years ago. And the Panama Canal closed only about 3 million years ago. Panama area. So again, circulation of the oceans. But you notice that now, because there's an opening at the bottom from both South America and Australia, we now have this cold circulation, and Antarctic is no longer heated by warm ocean currents. Hence, very gradually over time, it built up these enormous ice sheets 3 kilometers thick. So I just want to talk about what powered those ocean currents, because in science you want to think about where does the energy come from? These are big ocean currents. Well, here's the equator, the red line is the equator on the Earth, and I'm just going to heat up. The water is warmer at the equator and cooler at the poles. No surprise there. And you know, in the bathtub this morning, I did a little test. I filled the bathtub with freezing cold water, and I sat at one side of the bathtub shivering, and then I turned on the really warm water on the opposite side, and sooner or later I was sitting in a bath of tepid water rather than freezing cold water.